Okay, you can see the slides, right? So,
Yeah, we can see. Students, what about you?
Yes, ma'am.
Yeah.
okay, so let's maybe get started and then so today what I'm going to do is in the two sessions, I will start talking about some introduction to smart contracts. Basically, we can, just one second, let me reshare. Yeah. So I will get started with some introduction to smart contracts, again, taking some few examples. And then we will talk about some of the basic characteristics of the smart contracts. And then we'll go through the smart contract life cycle. So what are the different stages in creating a smart contract and things like that, so that we will go through them. And finally we will also see some of the applications of the smart contracts. Again, this is pretty high level applications, what it how they can influence different sectors, for example finance and public sector, governmental sector and things like that. So this is the main learning goals for today. So basically, start discussing about some simple examples to smart contracts and try to understand how it works. And again, what is the difference between the smart contracts and the existing traditional contracts? So how they work, and so we will discuss those things. And then we will also focus more on understanding the life cycle of a smart contract. We have four stages in the life cycle, like the creation and deployment and execution and completion. So we will try to understand what happens in each stage or each life cycle of these smart contracts. So the it's like unpacking the smart contract and see what are the different stages and which type of transactions they put into blockchain, and so more into that direction. And then, as I mentioned before, briefly, we will look into some of the applications using the smart contracts and how they can influence the some of the fields, mainly the finance and supply chain and the public governmental sector. We will maybe we don't touch briefly the challenges today, but in the next class I will briefly talk about the challenges, because it's smart contracts is also like a new programming language, right? Like and the complexity of the smart contracts comes from the fact that if you take the normal programming languages, they have a very good syntax and semantics, but they don't need to take a lot of assumptions about the underlying architecture. But on the other hand, smart contracts are a bit different. So they have to also understand and also embed the underlying architecture, for example, the blockchain on which the smart contracts, contracts are going to be deployed. That influences a lot of things. So that's why when you compare with the ordinary programming languages, smart contracting languages have several challenges. You can say that more challenges than the ordinary programming languages. So again, the reading materials. So basically, we use two books. So the Mastering Ethereum, Building Smart Contracts, and DApps. So this is one of the books which we use. It is also a very practical book. So focused more on developing smart contracts and programming using Ethereum. So this is a nice book which we follow. And then we follow some research papers. For example, the overview of the smart contracts, challenges, and the platforms. This is a very good paper from the Future Generation Computer System, which is also a very good popular journal. So, and then we will briefly touch upon some of the things. For example, decentralized organizations and the concepts around it, and also for the tokenization and the economics around the tokens and things like that. So we also do briefly touch upon the book as well. And the again, I have created a Dropbox folder. So this is the you can say QR code to the Dropbox folder, but this is the Dropbox folder where I will keep the slides and also the video materials, the recording of the lectures, and also the reading materials. Maybe let me go to this link. And if you are favorite of tiny URL, I also created a tiny URL, right? So let me reshare it. And I will show you how the structure is. So if you look into my Firefox window, so for example, let me here. So you have different folders. So courses, course reading materials, which contains all the materials, right? Like the 2 books and also the papers which are referred. And I also put some generic the papers like which talk about the from a pretty high level perspective as well. And then, so let me go back. So then I will copy the lecture recording here, and then you also have the slides. So I also copied the today's slides, and so you will have it everything at one place. So we will use this Dropbox for the whole course. So let me again share my slides. Okay. So let us get started with the smart contracts, introduction to smart contracts, right? Sir, can you share the Dropbox link over here? Yes, I can do that. So just give me a minute. I will put it in the chat. So I thought of doing it, but I forgot about it. Just 1 second. So yeah, both URLs, the Dropbox URL and the tiny URL, both are pointing to the same directory. So you can pick any one. Okay, so, and can you check where you have access to it, or does it ask you to log in? Because sometimes it can give problems. So if you can check it, then I can fix it right away. Does anyone able to access the folder? Okay, yeah. So it looks good. So, okay. So let's go further. So what is a smart contracts? First of all, if we look into the history of the smart contracts, the initial proposal for smart contracts were proposed in the 1990s by Nick Szabo, and probably you might have remembered Nick Szabo is one of the people behind the cyberpunk movement, right? So cyberpunk movement. So remember we had discussed this cyberpunk movement when we were discussing about the historical evolution of the ideas behind the Bitcoin and the decentralized computing, right? So Nick Szabo is one of the you can say the group, a small group. For example, Eric Hughes and Adam Back. Adam Back has proposed one of the digital currencies and things like that. Nick Szabo is also part of the cyberpunk group, which actually advocated for you can say the decent democratization of the internet. So, for example, they were advocating about the freedom of speech and free from censorship of the governments and all other democratic ideas. So this is a movement which is mainly, you can say, promoting the ideas for the decentralized computing, especially the ideas behind the, for example, Bitcoin, blockchain, and decentralized computing and all other things. So he's basically a computer scientist, but also a legal scholar. He has a degree in from law, and also a cryptographer working as part of the cyberpunk group to promote these democratization ideas. So first of all, what is a smart contract? You can say that a smart contract is nothing but a contract. You can say contract clauses. For example, the clauses from a contract which can be written into a computer program using a programming language, okay, which will be automatically executed when certain predefined conditions are met. So basically, this is nothing but specifying the conditions of a contract, or you can say the clauses of the contract, in using the programming languages so that you can execute them automatically. Again, based on certain preconditions, you will specify when the contract has to be executed, and if that precondition, one of the preconditions met with, and then the contract will execute automatically. So that is the idea behind the smart contracts. And so in a way, you can say that smart contracts are nothing but the automated script, because automated scripts containing of the transactions that can be essentially stored, replicated, and updated on the distributed blockchains. Again, when Nick Szabo when he came up with the proposal of the smart contracts, he has no idea, and at that time there is no idea of decentralized computation, or you can say the blockchain, and those ideas were still early. This was in 1994, right? So he was basically trying to propose a programming language or an automated way to execute the contracts in a digital form. So again, when we get back and when we compare with the smart contracts and the conventional contracts, so a conventional contracts must be completed by a third party, especially in a centralized manner, resulting long execution times and extra costs. So for example, let's say that we have a buyer and seller, right? And then buyer buys something from the seller, and then he has to pay some money for it and things like that. So then you have a set of intermediaries who are playing role in this example, right? So for example, a bank could be one of the intermediary who is transferring the money from the buyer to seller. And then you might also have a marketplace like Amazon. Amazon is, for example, an example marketplace where buyer and seller, they can exchange information and agree on those things. So you have this in the normal traditional conventional contracts. You have these third parties or intermediaries which play a significant centralized role, right? So that's why the traditional contracts results in long execution times and also some extra cost. And many times you need to trust the third party, right? So sometimes, most of the times, it might work well, but if the third party which you are trusting is not trustworthy, for example, if let us say that if a bank goes bankruptcy, or then you have big issues, right? So which involves a huge risk, and also the trusting is one of the biggest challenge, especially in uncertain environments, when you don't know the people, when you don't know the intermediaries. So the trust issues are become very significant. So the idea of smart contracts is you can integrate with the blockchain technology so that these smart contracts will make the dream of the peer-to-peer market. So without intervention of the third parties, so that people can directly communicate and directly transact, and things can be automated in a systematic way. So that is the basic idea behind the smart contracts. So let me run a small video. I think it's 4 minutes, and which explains the smart contracts from a very high level perspective.
Smart contracts are very popular nowadays, but what?
Can you hear the voice from the video?
Yes,
Yeah.
sir.
So,
are
thank
they,
you.
and what problems do they solve? The term smart contract was first used by Nick Szabo in 1997, long before Bitcoin was created. He is a computer scientist, law scholar, and cryptographer, so I'll spare you his exact words. But in simple terms, he wanted to use a distributed ledger to store contracts. Now, smart contracts are just like contracts in the real world. The only difference is that they are completely digital. In fact, a smart contract is actually a tiny computer program that is stored inside of a blockchain. Let's take a look at an example to understand how smart contracts work. You probably are familiar with Kickstarter, the large fundraising platform. Product teams can go to Kickstarter, create a project, set a funding goal, and start collecting money from others who believe in the idea. Kickstarter is essentially a third party that sits in between product teams and supporters. This means that both of them need to trust Kickstarter to handle their money correctly. If the project gets successfully funded, the project team expects Kickstarter to give them their money. On the other hand, supporters want their money to go to the project if it was funded, or to get a refund when it hasn't reached its goals. Both the product team and its supporters have to trust Kickstarter. But with smart contracts, we can build a similar system that doesn't require a third party like Kickstarter. So let's create a smart contract for this. We can program the smart contract so that it holds all the received funds until a certain goal is reached. The supporters of a project can now transfer their money to the smart contract. If the project gets fully funded, the contract automatically passes the money to the creator of the project. And if the project fails to meet these goals, then the money automatically goes back to the supporters. Pretty awesome, right? And because smart contracts are stored inside a blockchain, everything is completely distributed. With this technique, no one is in control of the money. But wait a minute, why should we trust a smart contract? Well, because smart contracts are stored on a blockchain, they inherit some interesting properties. They are immutable and they are distributed. Being immutable means that once a smart contract is created, it can never be changed again. So no one can go behind your back and tamper with the code of your contract. And being distributed means that the output of your contract is validated by everyone on the network. So a single person cannot force the contract to release the funds because other people on the network will spot this attempt and mark it as invalid. Tampering with smart contracts becomes almost impossible. Smart contracts can be applied to many different things, not just on crowdfunding. Banks, for example, could use it to issue loans or to offer automatic payments. Insurance companies could use it to process certain claims, and postal companies could use it for payment on delivery, and so on and so on. So now you might wonder, where and how can I use smart contracts? Well, right now there are a handful of blockchains who support smart contracts, but the biggest one is Ethereum. It was specifically created and designed to support smart contracts. Smart contracts can be programmed in a special programming language called Solidity. This language was specifically created for Ethereum and uses a syntax that resembles JavaScript. It's also worth noting that Bitcoin also has support for smart contracts, although it's a lot more limited compared to Ethereum. So now you know what smart contracts are and what problems they solve. I hope you enjoyed this video, and if you did, hit the like button and get subscribed. And as always, thank you very much for watching.
Okay, so let's proceed further. So before going further, so do you know what is a Kickstarter, which was mentioned in the video? Okay, I take the silence as no. So probably let me explain the use case, right? So for example, let's say that you have an excellent project idea, right? Let's say that you graduated from your bachelor's program or whatever the program you're studying. And then you are very entrepreneurial. So that means you want to start your own company. You have some excellent project ideas and things like that, but you don't have money to get started on the project, right? So What you can do is this Kickstarter is like a marketplace. It's a crowdsourced crowdfunding marketplace. What does it mean? So, like for example, like Amazon, which acts as a marketplace between the sellers and the buyers, right? So where both buyers and seller come to this marketplace to exchange or to buy and sell stuff and things like that. Similar to that, Kickstarter is a crowdfunding platform. So basically what you do is, let's say that you have an excellent idea and you want to set up a company and try these, you want to start the entrepreneurship, right? So start your own company. So then what you do is you will explain this idea and you will write what is the product you are making and what kind of advantages you have, what is the market scope and all the business plan and other kinds of things. And you will put it on the Kickstarter, saying that attracting money, investment to your project, right? So rather than going to the venture capital, going to a big venture capital who has money, who can invest into your company, this is another way where people will chip into money into your project. So it's like rather than going to a one venture capital and take money from one person, the whole, let's say the 80% or 90% of the capital required for your company. This is like you put on the Kickstarter, you put your project on the Kickstarter, and the people will invest into money. This is like the stocks you are selling into the small proportions, right? One good thing about it is like the Kickstarter, let's say that you need 1 crore rupees for your project, right? So your company needs an investment of 1 crore rupees to start the company and to start implementing your project. Right. So let's say you don't, and then the project will be advertised on the Kickstarter, and the people will start putting money into that. Right. So if you're able to, if your idea is able to collect minimum 1 crore of money, then the money will come to your project, or the money will be transferred to you by the Kickstarter, and you will give some kind of shares or debentures or whatever form to all the investors who invested into that idea. So then you can, when you get the money 1 crore, you can start your company and the project, and you can proceed like that, right? So there is some kind of guarantee you give to the investors who spend money, who put money into your company. On the other hand, let's say that your idea was not able to attract 1 crore. Let's say that only people, it was able to collect 25 lakhs rupees, right? Then what happens? Then the Kickstarter will not give money to you because you need 1 crore and you only got 25 lakhs investment from the different investors. So anyhow, it's not going to fly, right? So then what Kickstarter will do is Kickstarter will return the money back to the investors. So there is some kind of guarantee given by the Kickstarter, which is the intermediary, saying that I will only transfer this money if it reaches this threshold, like what it is required for to get started with this company, right? So that's why this Kickstarter, and there is also another couple of companies, crowdfunding platforms, where you can put your idea and things like that. And then one of the major things is, of course, Kickstarter has a good reputation because they have been doing very well and things like that. And of course, they will take some money, right? So for hosting the project and for promoting this project across different channels and things like that, probably they will take a cut in the investment and things like that. So in the use case, which we discussed in this video, is if we have a smart contracts platform perfectly built for crowdfunding, then you don't need to rely on this third party, and automatically all these conditions can be enforced. For example, if the project fails to attract the minimum amount of the money which is required for by the company, then the money is not transferred to the company, and all these guarantees can be implemented using smart contracts. Any questions on that? or comments?
Sir, then what is the difference between like a fully decentralized company and the company that runs on smart, like crowdfunding and which converts that to their use case?
Yeah, there are some subtle differences. We will see next class. I think in next class we will discuss about decentralized autonomous organization, right? So the idea behind the DAOs, you can say decentralized autonomous organization. So they don't rely on third party, for example, like a Kickstarter to attract the money or some other platform. And moreover, the complete decentralized autonomous organizations is a it's founded on the principle saying that okay, you have to build everything using smart contracts or even the bylaws of the company and many things. So basically trying to build a company over the decentralized principles is the idea of DAO, decentralized autonomous organizations. We will see. We will discuss that next week. But this is more like you go to some funders to get money for your project, right? So that is the difference. So still, the Kickstarter and other crowd platforms, they provide you some guarantee, but they also act as an intermediary by taking some cut in the investments, and so that is the difference. But yeah, one more thing to complement on that. So when once money is transferred to the company, the Kickstarters, they don't have any role. So that means so they will, if I understand clearly, I have never hosted idea on that, but if I understand clearly, they take their cut and they provide, they give money to the company, and the company will give shares to the investors, and then it is in between the company and the investors. So the third part, this Kickstarter will not play any role in that. Okay, so any other questions?
No, sir. Thank you, sir.
Yeah, but in case of decentralized and autonomous organizations, so we will see. We will discuss more in the next lecture. So we will try to build principles. We will try to build the organizations using the principles of the decentralization.
Yeah.
Okay, so let me. So let us go through now. What we will do is we'll take a small example use case. Just 1 second. So let me share it again. Yeah. So now what we do is we'll take a use case, again some e-commerce use case to so that we can understand easily, and then see where exactly the smart contracts can be implemented, and so how exactly that is done, right? So then afterwards we can go to the life cycle of the smart contracts. So let me take again a small example. So this is also an e-commerce application. Let's say that you have a buyer and a supplier or seller who is selling some products, and buyer who is purchasing some products, and then you also have a carrier or shipper who actually the transfers the goods from the supplier to the buyer, right? So we have 3 stakeholders in the use case: the supplier, buyer, and carrier, right? So very simple use case. Somebody is trying to buy something. Somebody, supplier is trying to sell something, right? It could be similar to the marketplace like Amazon, where, for example, let's say that a customer is trying to buy a T-shirt, from a seller who is selling on the Amazon marketplace. Similar to that, but we don't have the Amazon here. So everything is built on the blockchain and smart contracts, right? So we have three stakeholders: supplier, buyer, and carrier. So, and as shown in the figure, so this the first contract, let us say that the supplier has a list of a catalog of products he's selling, and then each product has the description and the quantity available, or you can say how many you can order, and price and availability and all other information, make it available through a blockchain, right? So this is similar to what we see on the Amazon. For example, let's say that there is a supplier selling T-shirts, a cloth manufacturer selling T-shirts on the Amazon. Then he will put all this information saying the price, quantity, and all other information similar to that. And let's imagine that there is the consumer or a customer who want to buy this T-shirt or this product, and then he will go to the blockchain and he will find the supplier. He can see that this supplier is offering the product which the buyer wants to buy. So, and the first thing what he will do is he will verify the reputation of the supplier. Right? A reputation is nothing but similar to the seller's rating on the marketplace. So, for example, when you buy stuff on Amazon, you will many times would like to see the rating of the product, and you can also many times you also want to see the rating of the seller. How good is the seller's reputation, right? So here also, since we have all the information about how many products the seller has sold before, and how many times did he fulfill the promises and things like that. So we have all the information, and let us say that we have a reputation built from this the historical transactions which happened in the previously, right? So that means we have this information about the supplier, which is offered in terms of some score or reputation, things like that. And if the buyer satisfied with the reputation of the seller or the supplier, then he will submit an order. So that means he will simply choose a certain quantity of the T-shirt and then places the order. And all this process will create one smart contract. So this is everything done in one smart contract. So whenever the buyer sends confirmation saying that or places an order, so everything is built into one smart contract, right? So this is the first smart contract which we see. And again, it's worth mentioning that there is no third party involved in this process. You have on one hand, you have the supplier who is selling the products. On the other hand, you have the buyer who is trying to buy some product, and everything is happening on the blockchain and smart contracts, right? So there is no Amazon marketplace like Amazon who is behind the scenes. So then what happens? So then the contract will be created. So that means let us imagine that the T-shirt costs 500 rupees, right? And the buyer want to buy one T-shirt. So everything was placed in order. Then the contract will be created saying that, okay, the seller will supply one T-shirt, and when the buyer receives it, then he will transfer 500 rupees to the seller, right? So that is the contract which we have. And then let us say that now the order has been placed, the first contract has been created. Now the supplier will try to find a shipper, or you can say the carrier, because he has to carry the goods from his godown. In this case, the promised T-shirt to and delivered to the buyer. Right. So then, again, the supplier will look on the blockchain for the probable shipping companies or the companies who can carry the product. So then they look into these transportation fees and source and destination and shipping time, how much time will it take and things like that, and what guarantees they provide. So if the product gets damaged and other kinds of things, and the supplier will will agree on choose a carrier, and then places his order, right? So let us say that the supplier has agreed with the carrier saying that, okay, you can get, let's say, 20 rupees or maybe 40 rupees for shipping this product from my warehouse to the buyer, right? So, and then the contract will be created. Again, again, no intervention of the third parties. Everything is done automatically. So when once the supplier orders this shipping of the product to one particular carrier, then this second contract will be created. Right? When once the process has been completed, let's say assume that the product has been shipped from collected from the godown, and then delivered successfully to the buyer, and then the payment process will come into play. Right. So this is the third smart contract, which says that, okay, if the product is received satisfactorily by the buyer, then the money will be transferred to the supplier. Let's say in this case, we agreed that 500 rupees. So that means if the supplier receives the product to his satisfaction, then automatically money will be transferred to the supplier, right? So again, similarly, since there is also shipping involved, so automatically when the delivery has been made, then the supplier will also transfer these 40 rupees of shipping fees to the sub carrier. Right? So all these things are built into the smart contract. So whenever the conditions have been met, so in this case, one of the condition could be like the receipt of the product by the buyer in a satisfactory condition, right? So when once he says that, okay, I receive the product and I like the product, so then automatically all the processes will start making, and then the transfers of the money will be automatically done. Of course, there are some other things involved, but let us start with the high level and see how things happen and stuff like that. So again, all these things are already happening, right? So what exactly is the innovation here? Because we have seen these things, this is not new. People have been ordering on the Amazon, and people have been ordering using the e-commerce applications for last maybe 10 years, 15 in India, and then e-commerce market have been growing extensively, and all these things are happening. So what exactly is the innovation here? Can anybody comment on it? What is the new here? Why are we saying that this is an innovative idea? The smart contracts is an innovative idea.
Immutability.
Yeah, immutability and also traceability. These are some of the things, right? So let's look into these one by one. So what exactly are the advantages of the smart contracts? Because this is nothing new. So we are just trying to improvise things, but most of the things, even without the blockchain and smart contracts, we are still able to pretty much do the things, right? So let's look into some of the advantages which we have. So the first of all, the smart contracts, they are hosted on the blockchain, right? And we have seen that blockchain is immutable. And we have discussed that extensively in the first course when we are discussing about the blockchain and the cryptocurrencies. So since they host on the blockchain, the smart contracts cannot be altered. So that means once you deploy a contract on the blockchain, it is like the permanent, right? Nobody can make changes. And the second thing is all the transactions involved in the contract, for example, the transfer of the money and also the orders and other kinds of things, all these things, they are created as transactions on the blockchain. So we can easily, so they are there for permanently, and you can easily use them as some kind of trace. So that you can also audit the behavior of the different stakeholders. Right. So, for example, you can easily build a reputation system like the Amazon the ratings or something like that to see how the supplier and the buyers and carriers they behave. And so this is a very good way of immutable reputation system which you can build. Right. So, and therefore the malicious behaviors and the financial fraud can be easily mitigated. And most importantly, reduce your costs. So you can easily reduce a lot of administration and service charges because you don't have a third party taking some money. And more than that, smart contracts on the blockchain, they can be automatically triggered in a decentralized way. Whenever the conditions met, they will be automatically invoked, right? So that will definitely reduce a lot of administration and service charges because you don't have the third party in between them. And also efficiency gains. So improving the efficiency of the business processes. So for example, let's say that since you eliminate the dependency on the intermediaries, so the overall performance of the process will significantly increase. And for example, in supply chain or in financial settlements, and all these things will be automatically executed without any proper problems. And so the transaction turnaround time will be greatly reduced. So that means things can be settled very fast. Right. So let's go look into the lifestyle of the smart contract. Right. So let us dissect what are the different life cycles of a smart contract. Right. So again, smart contracts proposed as a computerized transaction. I was telling you before, when the initial version of the smart contract was proposed, there was no notion of the blockchain, right? There was no underlying immutable infrastructure available at that point of the time. But the basic motivation for the smart contracts proposal was they were proposed as some kind of digital transaction language, you can say, digital transaction processing language. So even though it was proposed in 1994, it hadn't received a lot of recognition because the purpose is to automate the processes, especially the transactions, in an automated way by specifying the clauses of the contract in a rule-based system. Right. So the reason for not getting a lot of attraction from many people is that it doesn't have the underlying infrastructure which can on which they can be executed. Right. So even though it was in 1994 proposed, but they haven't been came to limelight till we have the blockchain technology. The reason is smart contracts needed some kind of immutable underlying infrastructure, which the blockchain fulfills. We can see that the successful blockchain infrastructures came only after 2009 and 2010 when Bitcoin was quite popular, right? So that's why the smart contracts were not very much known till the evolution of blockchains. So the basic idea is that the contractor classes are embedded into smart contracts, and automatically they can be enforced when the certain conditions is met, right? So basically what you do is you will specify the clauses of a contract in the form of if-else rules, so that whenever the specified condition is met, automatically you can execute the contract. And once you write them in the form of a smart contract, you can assume that smart contract is nothing like similar to a program. For example, when you write a program in Java, what you do is you can build into bytecode, you can compile it, you can produce a executable out of it, right? So similar to that, smart contracts are also developed and then they can execute it. They can be compiled to the executable programs, which will be deployed on the blockchain. So basically, you can assume that smart contract is nothing but some kind of rule-based constructs using the programming language. So you will see a lot of if-else statements specifying the conditions. Okay. So the important thing is the execution of each smart contract statement is recorded in an immutable transaction. So all the stages are recorded in the form of a transaction, which actually is stored in the blockchain. So that gives a lot of the confidence, because the underlying blockchain is immutable. So the transactions are recorded permanently, and once the condition in a smart contract is satisfied, so automatically execution, the corresponding functions can be executed. And you can also specify what you can say access rates at the function level. So that means there is a very good scope for defining the fine-grained access controls on the function level and things like that. So when we look into the life cycle of a smart contracts, there are 4 stages: the creation, deployment, execution, and completion. Let us see with each state what happens. So this is the overview of the 4 life cycle of a smart contract. So we have the creation stage, where a lot of negotiation happens, and you have the deployment stage. Then once the smart contract is developed and tested and felt satisfactory, then you will try to deploy to one of the existing blockchains, for example, Ethereum or some other blockchain blockchain architecture. And then once the smart contract is deployed, it can be executed based on the preconditions you defined in the smart contract. So automatically get executed whenever the conditions are met. And finally, when the smart contract has executed, then you can also call the final stage as completion, where you will release unfreeze the accounts, and there is some kind of some kind of process is happening. So when we say that the smart contract is completed, and then you can archive it. So let's see what happens in the case of creation, right? So in case of creation, first of all, based on the business process you are trying to write a smart contract for, you need to first understand the important the business problem and understanding and things like that. So it involves a lot of stakeholders. For example, let's say that we have a very simple the smart contract containing 3 or 4 stakeholders, and then all of them, they have to sit together. They have to write what are the conditions between them, and so there will be a lot of multiple rounds of discussions and negotiations and agreement. Again, let me take a very simple example. We have seen this buying of T-shirt on the through the smart contract, right? Let's say that we have a seller, we have a buyer who buys stuff, and then we have a carrier who actually ships the product from the seller to the buyer, right? We have seen this previous example. Let's say that what happens let's imagine that what happens if the carrier damages the goods during the shipping process. Let's say that somebody has bought a nice, beautiful glass pot, right? And then the carrier, while shipping it to the buyer, made some things happen, and then the product was damaged, right? Who is responsible for that? So maybe all these kinds of conditions will be discussed and they will be agreed upon. So you will have multiple stakeholders. So in this case, let's say that supplier agrees to pay some damage if the product is not delivered perfectly. Let's imagine that if the product is damaged during the shipping process, during shipping it to the buyer, then let us imagine that the carrier will take the risk or the responsibility to bear the cost, right? So those conditions will be agreed upon before, and then maybe in this case, if the product is damaged during the shipping, the seller, the carrier will pay the full price, right? So something like that. So these kinds of terms and conditions will be discussed beforehand. So that is the reason you will have multiple discussions and negotiations and agreement between each other. So this is what happens during the negotiations and trying to figure out what are the exact conditions you want to put into smart contracts, right? So it can also involve a lot of lawyers and counselors and many parties, because since maybe the money is involved in these conditions, right? So a lot of monetary transactions are involved. So then definitely you would like to have the legal experts are also a part of the process, right? When once, let's say that all these the conditions have been finalized, right? So, and everybody has agreed and they drafted this initial contractual agreement. In the normal traditional processes, what happens is you will have this contract and everybody will sign it, right? And then things happen out of the way. Things happen in the normal process and things like that. So you will have a piece of paper signed by everyone. In case of smart contracts, what happens is now you will have the software engineers who will convert this contractual argument, you can say the contractual agreement. So you have an agreement specifying in detail what happens in each stage and what happens in different situations and things like that. And then the software engineers, they will develop smart contracts for it, right? So basically they will understand the clauses and then they will try to encode the clauses using the programming logic. For example, in case we use Ethereum as a smart contract platform, then you will use Solidity, which is a language used to write the smart contracts, and then they will convert these things into a smart contracting language, right? And so again, this is like a small software project, you can say. Like any kind of software development, it will have different stages. So for example, you need to think about the design and implementation and what type of things you need to implement it, whether you need wallets or you need the dependencies and other kinds of things. And once the smart contract is developed, it needs to be validated. What does it mean? So somebody has to see the contract and compare with the original legal contractual agreement and see that the smart contract will implement all the clauses, has implemented all the clauses from the contractual agreement. So that's why there is a lot of validation going on, and you can also see that this is the testing. So people will test the smart contracts to see that it behaves exactly as they have specified in the contract. So that's why creating a smart contract is a very iterative process. So that means, like any kind of software project, project lifecycle, you develop the code and you will iterate and you will test it and fix the bugs and again deploy it and test it. All these processes will happen. So again, meanwhile, it also involves a lot of stakeholders such as lawyers, software engineers. So this is a quite different scenario when you compare with the software development. Mostly you will have only the business people involved in it. But in this case, since we are actually automating the contractual obligations and transfer of money, so you also have the lawyers and legal experts involved in this process. Let's say that we have gone through all this process and we have developed the smart contract. We have tested the smart contract, we have validated the smart contract to see that it actually implements the contractual clauses which we put into the original agreement, right? So then it goes to the deployment phase. So let us again, for the sake of simplicity, let's choose that we have a Ethereum platform, which actually one of the popular platforms for smart contracts. Let's say that we deploy it on the Ethereum. right? So then what happens in the deployment phase? The validated smart contract is deployed to the platform on top of the blockchain, in this case, Ethereum, let's say, and the contracts are stored on the blockchain. Again, remember, since Ethereum is a blockchain, then once you deploy the contract on the Ethereum, you cannot change it, right? Let us say that we identified some bug. We want to modify the contract, which is not simply possible because modifying anything on the blockchain will make it invalid because the linking and hash linking and all these things will fail. So that means once you deploy the contract, you cannot change it. It's both good and bad. It is good in the sense that it offers us the immutability. So we are pretty much sure that nobody else can change anything. If they change it, we can easily identify. So that is the good part of it. The bad is that you cannot modify the contract. So what you do, you simply, let's say that you identified a bug after deploying the contract. You can simply take the contract from the blockchain. So take means not deleting data. You will make the contract inactive, and you will create a new contract, and you will deploy a new contract overriding the previous contract. Overriding means not replacing the data. What I mean to say is telling all your stakeholders, saying that this is the latest version of the contract, right? So please refer to 1.2 version of the contract version 1.2, not the 1.1 or something like that. Right. So, and then it also involves a lot of other nitty-gritty details. So, for example, let's say that we have two parties are involved in the smart contracts, and there is also some kind of the money transfer involved. So then the digital assets of the both parties involved in the smart contract are locked by freezing the corresponding digital wallets. So that means there is also some kind of housekeeping happening. So because it needs to promise the contractual obligations, right? So that means it will also freeze the connected assets. For example, in the case of digital wallets, maybe in terms of the cryptocurrencies or some other form of the digital asset. So all these digital assets will be blocked for the entire execution of the contract. So for example, the coin transfers, either incoming or outgoing on the wallets, are locked, or you can say blocked for the time being. So that means you cannot use these coins in any other transaction. So those are frozen for the period of the contract execution. And one more thing is here we will have digital wallets. Again, I will discuss about digital wallets a bit later. So that means the parties can be identified the digital wallets because they are also involved in creating the smart contracts. What happened in case of execution? Any questions so far? Okay, so what happens in kind of execution? Yeah, go ahead. Yeah, please go ahead.
Sir, in the example you have provided of supply chain, there when a seller sells a product to a buyer.
Yeah.
So first the buyer will see those reviews of the seller of the previous transaction. He will verify those previous transaction whether he is an authorized seller or not.
Yeah. Yeah.
So depending on that, he will create a transaction, right?
Yeah.
So you said that after the transaction, the smart contract is created. But according to the definition, smart contract is of predefined conditions, right? But here the conditions are being made on that time.
Yeah. So yeah, maybe let me elaborate a bit, right? So we haven't looked into fully how these things are implemented, right? So for example, let's take, for the sake of simplicity, let's take that buyer as liked a product and he made some kind of purchase order, right? So a purchase order, what happens in case of purchase order? Let us again take the example on the Amazon, then we can apply to these things, right? So let us say that you're buying a t-shirt on Amazon. When you make the order, you need to give some guarantee that you will pay the money for the product, right? So what you do is probably you will use your credit card and put the information, and you create an order, right? So the Amazon won't deduct money at the time of you making an order, because it only needs the guarantee that, okay, this guy will I have this credit card information so that I can take money from his account later, right? So once the order is shipped, the process, and then the order is forwarded to the supplier, and the supplier agrees that, okay, I have the t-shirt, I will supply. And when all this process is done, then the Amazon will take money from your card, because now it knows that supplier will supply, right? So that is what happened in the normal traditional e-commerce application. Now let us see how this happens in case of using smart contracts, right? So when you make an order similar to that, again, there are a lot of applications interfaces are missing in this case, right? So still smart contracts is evolving, a platform evolving, and things like that. So let's imagine that you have a similar kind of interface similar to Amazon, where you can use the underlying blockchain to order this product, right? In this case, what you will say is, okay, I like this product and I want to buy this product. And then when you comes to the time of giving the guarantee to your payment, here in this case, you don't give the your credit card information. On the other hand, you will give the information about your wallet. So we will discuss about the wallet. So you will have a wallet, digital wallet, where you have some coins. Let's say that you have 2 Bitcoins in the digital wallet, and then you will provide the wallet information saying that, okay, I want to buy this t-shirt, which is 0.005 Bitcoins. And this is my wallet information. I have the sufficient money. So then you will make this order, right? The smart contract is specified loosely while developing, saying that, okay, you have some buyer who want to transact with the seller. They need to provide the wallet information and some kind of guarantees. So when what happens is, then all this information will be used while executing the smart contracts, saying that what is your wallet information, the wallet address, and other kinds of things, and the amount of money you have been asked to provide guarantee. For example, in this case, 0.005 Bitcoins, and all these things will be encoded, used as part of the smart contract execution, and then that will be made into the transaction. So in this case, your 0.005 Bitcoins will be frozen when the smart contract is being executed. So that means when we create a transaction saying that, okay, we have a seller who agrees to buy this t-shirt and who provide a guarantee of 0.005 Bitcoins with the wallet ID 1234, and all this information is created as part of the transaction and put into the blockchain. So maybe I was trying to describe the things from pretty high level, but you have a lot of information which will be put into this place. Did I answer you correctly, or still any questions?
Yes, sir. Thank you, sir.
Yeah. So the smart contract, again, let us apply this case to the life cycle, right? So what I mean to say is, yeah, in this case, maybe if we apply the same use case, buyer, seller, and shipper, and all other things into the smart contract application platform, maybe you will have a buyer and shippers, and you will have the supplier and shipper, and some other entities are involved in creating the smart contracts. Maybe the buyer is not into picture, because if you want to use this smart contract for selling any goods you have in the product catalog, and you don't know which buyer will come and buy it, right? So then the smart contract will have some kind of how can I say, open variables, open things where you can easily plug in the buyer information and things like that. So the contract will be designed like that. So you have some fixed things specified. For example, what is the wallet of the supplier because he need to receive money. Maybe what is the wallet of the carrier if we have a carrier also part of the smart contract and things like that. All this information is encoded as part of the creation stage, and maybe some information which will be passed on to the contract at the time of execution. For example, let's say we deploy the smart contract. Yeah.
Sorry to cut you off, sir. So is it like
Yeah.
it is working on a need to know basis?
Yes, yeah, that's right. Yeah, need to know basis, or you can say more configurable approach, right? Like let us say that maybe let me give an example about the class, right? So for example, you know the classes in Python or in Java or C#, whatever it may be, right? So when you create a class, you have a constructor, right? The purpose of the constructor is to provide necessary data so that we can create the class in the way we specified, right? It forces you to provide information. If you think in that case, maybe the smart contract, when you create an instance, when you execute the smart contract, then you need to provide the buyer wallet information and also the amount of money the buyer has to pay. So these are the two necessary parameters for this smart contract. So whenever you create an instance of smart contract, or you can say you execute a smart contract, this information has to be passed. So the contracts are definitely written in a sense that they can be easily reusable. Otherwise, we don't create a smart contract for every buyer who want to buy some product, right? So then you will end up creating thousands and millions of smart contracts. So yeah, so need to know basis, and information will be provided at the time of execution as well. Okay, so let's proceed further. Any other questions? Okay, so what happens when it comes to the completion stage? I think we covered the execution stage. So yeah, I think we covered only the deployment stage, right? So yes. So what happens in the case of execution stage? So after deploying the smart contracts, the contractual classes are monitored and evaluated. So that means you will specify some conditions, right? Saying that, okay, these are the conditions. If these conditions are matched, then you can execute this contract, right? So again, rolling back to this previous simple example of buyer, seller, and shipper, right? So in that case, maybe one of the conditions which we specify is there is a buyer who invoked the smart contract by providing his wallet information and by providing this money, let's say 0.005 bitcoins or something like that, right? So these are the conditions for execution of the smart contract, and then they will be automatically executed, right? Or you can say that another example could be like, let us say that the buyer received the product satisfactory to his satisfaction, right? So he received the product and he liked it, and then he will say that, okay, I say that the order is completed, and then that could be a predefined condition for transferring all the money and things like that. So then this execution will happen. So when a condition is triggered, the corresponding statement will be automatically executed, and consequently the transaction being executed. One important thing I want to specify here is, you can see in this diagram, so that's why I put this diagram in all phases. So while creation, you have a lot of development happening, right? So basically you are developing the smart contract. Once you deploy to the blockchain, then it becomes immutable, right? So that means you will deploy to the blockchain, and when you deploy to the blockchain, it will be a transaction will be, you can say, I don't say call a transaction, but some information is written to the blockchain. You can say, you can also say a transaction, saying that, okay, now we have this contract available on the blockchain, right? So all the miners will also have the information about it. And when we execute the contract, right? So when the conditions met and things happen, again, at the stage also, we generate a transaction and put into the blockchain. Similarly, in the case of completion stage as well, when all the assets were unfrozen and things like that, and then information will be written into the blockchain in the form of transaction. So what happens in the case of completion stage? So after the smart contract has been executed, the new states are involved in the parties are updated. So that means, let's imagine that the t-shirt has been shipped perfectly and received by the buyer, and he confirms that the order is fulfilled. Then let's say that the contract is executed and all the money and everything will be transferred automatically, right? Depending upon how we write the contract and things like that. So, and the digital assets have been transferred. So in this case, 0.05 Bitcoins are transferred from the buyer to the seller, and the money is transferred. And if there are shipping costs, then automatically there is another maybe smart contract transferring money from the shipper, money from the supplier to the carrier, and all other things will be transferred, right? And the most importantly, the digital assets of the involved parties have been unlocked. So that means then there is some kind of locking, because we need some kind of guarantees, right? So, and once the contract execution is completion, then these accounts will be unlocked. So the smart contract is completed and all the state will be written to the blockchain. So basically, you can see here all the information. Here we write it to the open blockchain. Again, if you compare this with the traditional contractual execution, right? Not smart contracts, traditional contract execution. So you might have different databases here, right? So for example, you might have the supplier database, you might have the databases of the shipper or carrier, and many parties involved, right? One important distinction is all those databases, for example, the databases given by the shipper, given by the supplier, or the systems maintained by the supplier, and the databases is local to him only. So they don't have any visibility to the other parties. But in this case, you can see here, we use a public blockchain as a database to store information. And what information is that? In the form of transactions and things like that. But this is a global state, right? So everybody can see it. And all these transactions generated at the deployment stage, execution stage, completion stage, at different stages are replicated across different nodes. So all the miners, all the nodes who maintain the blockchain, they will have this information. So that is exactly the main difference between the traditional contractual processing and the smart contractual processing. So since the information is available with everyone, no single one has the control over the process. So it is like so that's why it offers immutability and a lot of other better properties. Okay, so let's proceed further. So, and one of the important things we need to have for the smart contracts is the account-based ledger. So again, I don't know how many of you have still remember the discussions we had on the transaction-based ledgers. Then we were discussing about the cryptocurrencies. So let's see what is the difference between the transaction-based ledgers and account-based ledgers. So remember when we were discussing about the cryptocurrencies, I was saying that the cryptocurrencies, they use a transaction-based ledger, right? So we were discussing about the transactions and the in the form of transactions in the form of immutable coins, and we argued that the transaction-based ledger is quite convenient because it is easy to verify. Like we were discussing at that point of time, if you want to verify a transaction, then we have the finite amount of transaction to scan. So that means you just need to go and look into the source of the transaction and verify that. And if you can verify that, then everything is good, right? Because the transaction-based ledger is built on the immutable coins, right? So we have discussed these things. So basically, the coins are stored in terms of the unspent transactions or UTXOs, and each unspent transaction has a quantity. And then the way you create the transactions is by combining different coins from the unspent transactions, and you can create a new transaction, right? So basically, what I'm saying is the transaction-based ledger is quite convenient for the cryptocurrencies because of the finite state verification, right? So we said that account-based ledgers are quite bad for cryptocurrencies because if you have an account-based ledger, then what you have to do is you have to go and verify all the till the Genesis block to see which transactions are made into this account, which transactions are deducting money from this account, and things like that. So spending all unspent transactions are nothing because, again, we were discussing about the immutable coins. So that means if you have a transaction, let's say that I have a transaction where we have the Bob having 17 coins, right? So this is the transaction where Bob got 17 coins. And when Bob want to use this transaction, use coins from this transaction or assets from this transaction, he can only do it at once or nothing, right? So that means what I mean to say is he cannot say that now I have 17 coins. I will use 5 coins from this 17 coin transaction. It doesn't work like that. What we said is you can only use all the coins at once. So that means the coins are immutable, right? So the transactions are immutable. So that's why we say that the transaction-based ledger is quite convenient because it allows us to go for the finite scan of the transactions, and the transaction verification is quite easy because it is stateless and many advantages, right? So, but on the other hand, when we come to the smart contracts, so this kind of transaction-based ledger won't work like that, right? So because users think, so let us look into why we need account-based ledger, right? So in contrast to the cryptocurrencies, the smart contracts forced blockchains chosen to employ the account strategy. So this means you have some kind of wallet, and the money is stored in the wallet, similar to the account-based strategies. Instead of having each coin uniquely different, coins are represented as balances in the accounts. So the accounts either controlled by a private key or a smart contract. You can also have a smart contract controlling an account and things like that. And one important distinction is the transactions in the transaction-based ledger are stateless. The reason why I'm saying stateless is, so if you take a transaction, it has a limited information, right? So the source and nothing else. If you so you can take any transaction, and if you want to verify the transaction, you just go to the source and verify. That's it. So that helps us to execute the transaction in a very parallel way. So that means you can simultaneously execute the transaction because of the statelessness. You can do a lot of parallel passing. So that means if you have, let's say, 100 transactions, you can verify them parallelly without having any kind of dependency. But in case of account-based ledgers, remember how the account-based ledgers are maintain their balances. So you will see which coins have transferred into this account, which coins have been, how much we deducted or transferred to other accounts. So that means credits and debits. So you have to match all these things to find out the balances, right? So that means account-based ledgers, they have a lot of state. So that's why they are called the stateful. So that means having the account-based ledger, you cannot parallelize, or you cannot do the parallel execution for the account-based ledger, similar to the transaction-based ledger. In case of transaction-based ledger, what you have is you have the transactions which are stateless. So that means no state is assumed as for the transaction. So that means you can pretty much, let's say if you have 100 transactions, you can run 100 parallel threads or parallel processes to verify them simultaneously, concurrently and simultaneously. But in case of smart contracts, which needs the account-based ledger, because the account-based ledgers are stateful, they contain existing state as part of the execution of the smart contract. So they cannot be done concurrent execution. So that means you have to follow certain rules. Let me take an example to show why it is important, this statefulness in case of account-based ledger. Let's say that the balances are all listed. Let's say that we have 100 ethers. Ether is a currency, right? Like some kind of the currency on the Ethereum, let's say. And I can send you 5 ethers. And then let's say that we have a contract where it deducts 5 ethers from my account and transfer to you, right? So, and then if we execute the smart contract once, then we have 100 ethers and then deduct 5 ethers and we have 95 ethers in my account. Let's imagine that. And you have the 5 ethers which is transferred to you. But if the system is not carefully designed and the transaction could be replayed, so for example, if we don't take care of all the possibilities, saying that somebody can rerun the transaction or replay the transaction, like in case of double spending attack or something like that, you can rerun the transaction. Then what happens? Since this is an account-based ledger, it will automatically deduct 5 more ethers and transfer to the other party. So then the first party will be left with 90 ethers and the second party will have the 10 ethers, right? So that's why this is happening, because the account-based ledgers are not stateless. So they are stateful. So that means you need to also think about whether whether the smart contract is executed or not. So all these things have to be taken care while designing the account-based ledgers and the things like that. Okay, so more flexible transactions. Transaction depends upon the existing state and can have divergence effect. So again, you can do many things. For example, in this case, based on the account, the status of the account, let me go here. So for example, when I have 90, let's say that 90 ethers in my account, then I can define conditions based on the state, saying that if you only have 90 ethers in my account, then stop executing all the further requests or something like that. Or maybe let's say that if I have only 90 ethers in my account, then maybe get money from the other account and deposit into this account or something like that. So you can, basically what I mean to say is you can use this stateful information and you can specify the conditions for further executions. So the existing state can have the diverging effects, and you can also use it for writing different conditions and things like that. And the transactions do not explicitly include the resulting state into smaller transaction, right? So basically, so again, the care must be taken care in executing them, because you cannot simply run in parallel. So since they have the state, so for example, again, let me take this 5 ether case, right? If I execute the same transaction 2 times in parallel, then you will get undesirable effect. We wanted to deduct 5 ethers, but let us say that if 2 nodes try to execute this transaction in parallel, then you will have adverse effect, right? So that's why the parallelism is really not implemented in the smart contracts. So normally what happens is the account-based models, they encourage you to execute 1 transaction at a time for each account or something like that. Okay, so let's quickly move on to some of the applications. So there are plenty of the applications, right? So again, the smart contracts, they have a big scope for automating many processes in the different sectors. I give some of the examples from different sectors. So let's look into this Internet of Things. So we see that nowadays many Internet of Things and the sensors and all other things are happening, especially in case of health systems. For example, if you take an example of the process in healthcare example, even when you go to a doctor and when you go through an operation or something like that, there are many sensors reading the various parameters from your body, right? So similarly, you have a lot of smart objects, or you can say IoT devices, reading several information from the environment. So these things can the data, since the data is pretty much available, you can really write several smart contracts to automate these processes. Especially, there will be a lot of changes in the manufacturing industry, because reading the data from these sensors is quite stable, in the sense that quite dependable, right? So if you have a sensor, it reads the information at a different frequent intervals, and also more reliable. The sensors are more reliable, so that means you can easily write several smart contracts in the manufacturing industry. So that means there will be a lot of changes in the manufacturing industry in the coming years, especially based on these automated sensor. Automatically, you can automate a lot of processes. So supply chain and e-commerce, again, you will have. We have taken this example of the marketplace, right? So e-commerce has been quite popular in the last 15 to 20 years after the advent of the internet and things like that. So the next stage will be, or you can say the smart contracts will play a major role in the e-commerce system. Even I'm not assuming that Amazon will fade away, or marketplaces like Amazon will go away or completely disappear in future, right? So I'm not saying that, but there will be a lot of things can happen, right? So, for example, now Amazon is playing a major central role in the marketplace and things like that. So in future, there could be marketplace evolving out of the smart contracts based platforms. So, for example, let's say that if we build a marketplace based on the purely smart contracts, and then offer the similar functionality, people definitely choose that one, because now you can mitigate or lessen the role of the intermediary like Amazon. So that means you will also have reduce the cost and things like that. Even the marketplaces like Amazon, they started using cryptocurrencies, and they will use a lot of smart contracts because they can automate a lot of processes. Many times, if you look into their processes, these are nothing but just simple contracts which contains a bunch of rules saying that, okay, what happens if the buyer fails to pay, right? And what happens if the shipper damages the goods? What happens if the supplier fails to fulfill his obligation to supply the product on time? All these things are written in the form of rules, and then we can see that a lot of transformation happening using the smart contracts. And then we were discussing about distributed and autonomous corporations and decentralized organizations, which can build basically on the foundations of the smart contracts and blockchain without the human involvement and things like that. So then you can easily automate several things. And they will transform a lot of conventional supply chains, right? So for example, supply chains is one of the industry which will be affected a lot by the smart contracts, because again, you have multiple parties and you have trust problems in between them, and you can easily write them into form of rules, And then if it is a smart contracts executing on the blockchain, then everybody is happy, right? So because they can see that it is immutable, you can easily track the whole track and trace everything. So that is by reason why supply chains will be easily going to be affected a lot. Finance. So again, the banking and financial industry are one of the most important industries, especially in case of data analytics. These are the ones who embrace the ideas. Even if you look into the decentralized computing and things like that, it is the cryptocurrencies which catch up these ideas of the distributed decentralized institutions, right? So, and there will be a lot of changes in the finance. So the traditional capital markets suffer a long-term settlement cycle. So for example, in some cases, the settlements will go up to 20 days in the traditional process. But if you automate the process, again, automating means that means we don't completely remove the human from the loop, right? So automating means what we say is, let us say that now we take 20 days to process things because there is a lot of manual intervention by the people who has to check manually, manual checks and things like that, right? So when we made this process or when we automate these processes using smart contracts, you will have human intervention, no doubt about it. So only thing is, since they are automatically executed, probably you will have one or two people who are checking whether the executions are going according to the norm or things like that. So that means you will try to automate all the repeated processes, which can be easily expressed in terms of the defendant's rules. So it is an expectation saying that maybe the processing times can reduce from 20 days to 6 days or something like that. So which is a pretty big jump in the financial industry. So it can bring around 5 to 6% of the demand growth in the coming years and things like that. So again, there will be a lot of changes in the commercial banking and retail banking. Where banking, especially, they have a predefined rules. So these things can be easily automated. It is actually similar to what we have seen when we have these computers introduced to banks. Probably you might not aware about this one. So in the years around maybe 2000 or before 2000, there was a big suspicion among the people, especially the banking employees, because when we say that the banking, the computers are being introduced into the banking industry, then people thought that it will take away jobs of the many staff in the banking industry, right? But on the other hand, what happened is the banking processes were automated, digitalized. I don't say automated; they were digitalized, and it has increased the breadth and the accessibility of the banking operation. So it really actually expanded the banking operations a lot, rather than completely eliminating the human forces and things like that. Similar to that, even automating the contract using smart contracts automation, the automations will help the performance of the processes. Thereby, it will lead to the more expansion and things like that. For example, if you take the mortgage loans, getting a loan for your house or something like that, it takes so much time, right? Like maybe 1 month and things like that. And those things can be automated, and maybe the gestation period can be reduced to few days or something like that. So these are things which can happen in the future. And insurance, again, insurance has a lot of potential to be automated because it can reduce a lot of overhead. So there are multiple parties involved in the motor insurance. For example, so you have the insurance on one hand, you have the customers, and you have the garage who can handle the vehicle repairs and things like that. You have the transport provider, hospitals, and all these multiple parties, they are involved. And there is a lot of contractual agreements which can be automated. So this is a very good fit case for these smart contracts. So they can automate the settlement claims by sharing the legal documents on the distributed ledger, and many things can be easily simplified, right? So also the passenger who purchased the flight insurance can automatically sign a smart contract, and which can easily check and verify. Now let us take an example of this one, right? So this is a pretty good example. Let's say that you bought a passenger. You are buying a ticket, you are buying a flight ticket, and you are traveling on flight, and you bought a purchase insurance. Let's say that your flight got delayed by 5 hours, right? And then you need to get this insurance from the insurance provider. Now what happens is you upload this boarding pass, and you upload the proof saying that the flight got delayed and things like that. You will give your flight number and all this information. And on the insurer side, somebody is sitting there and looking them into manually and checking that whether the flight has actually delayed on that day and how long it will delay, and whether it is within the clauses for the reimbursement of the money and things like that, and then give sanction, right? So for example, let's say that we have a smart contract defined for it. Let's say that if the flight is got delayed by more than 4 hours, you are eligible to get a compensation, right? So you are eligible to get some money as a compensation from the insurer. You can easily encode that information into a smart contract, and the smart contract, when you invoke it, it can get information from an external oracle. So for example, a database, maybe a database showing when the flights, showing the idling of the flights. So that means when the flight has takeoff and when the flight has arrived, and if there is any delay, all this information can be provided by external oracles. And based on that, if it finds that the flight got delayed by more than 4 hours, then the money can be automatically transferred to you. So these things can be easily automated, because you don't need to have a lot of manual work in this case. So these are the simple cases, very easily can be automated in the coming years. And again, sharing economy. So for example, Airbnb is one of the popular sharing economy platforms, and they involve different kinds of stakeholders. So for example, on one hand, you have people who are providing houses, and on one hand, you have people who are renting the houses and things like that, right? So, and you can easily build a smart contract platform for sharing economy, which can give you the reputation and which can give you the auditability, and all these kinds of things can be easily available by using the smart contracts. Yes. And in public sector also, you will be having a lot of things happening because, for example, property registration and the land registration, these are some of the worst processes in the public administration, right? Like because lack of the digitalization of the records and many things, they became the source for the malpractice. And using smart contracts and underlying the blockchain architecture, so you can mitigate a lot of risk and malpractices, and also the fraud. These kinds of things, they can be used in the coming years. And the most important thing is blockchain-based voting system. So people have been also trying to use blockchain for voting, because it provides the immutability, right? So nowadays we use voting machines, not only in India, everywhere, right? Even in US, they have the electronic voting machines. And one of our previous colleague at IT University of Copenhagen, he has proved that these machines can be easily hacked. So that means they are not hack-proof. So many things can happen. But on the other hand, when you have the blockchain and smart contract-based system, which provides necessary guarantee of anonymity, and at the same time, the scope for verification and validation, and it can easily provide a very transparent system for voting. So people have been mainly working on the e-voting protocols, especially using zero knowledge proofs. So zero knowledge proofs is a kind of you can say mathematical techniques to provide some guarantees about the data without revealing information. So these things will come into picture in the coming years. Right here is a summary of different benefits you can have, and some of use cases you can go through it. Okay, so I think we are coming to end. So any questions or comments? Okay, if you don't have
Professor,
any.
thank you. It was a nice one. Actually, in the previous classes, we had the ideation phase of the projects, and mainly many projects they aligned with the use cases that you have shared,
Okay.
either in public sector or in insurance. Many students they have some ideas. I think I'll make a document and I will let you know. At your free time, you can go through and you can give how it can be practically applicable, because we were wondering all those project ideas, what would they cost with respect to scalability, practical implementation, computational complexity, all those things. So, but many project ideas were aligning to this particular use cases that you have shown now.
Yeah. So again, the students will develop their projects during the course, and then they will submit as a project, right? So
Yeah. They should.
maybe we can let's do one thing. When we went through the programming of the smart contracts and finished those modules, then we will have 1 or 2 sessions dedicated for their project presentations, and then
During
we
those
can ask them
hands-on
to
sessions,
present.
yeah.
And then we will provide feedback, and then they will also have a good knowledge by that time.
Yeah, that would really help them.
Yeah.
Students, your feedback on this?
Yes, ma'am. I think that's a good idea. The workflow is it's much efficient, so that we'll also have some knowledge, some back-end understanding before it proceeds with the process.
Yeah.
Ma'am, very informative, ma'am.
Okay. So you start developing your project prototyping, or I think everyone now you are aware of the use cases that what the professor has shared, and I think 90% of the class has shown me project ideas based on this only. So you can start working on this, and as per the schedule, we can have the project, the things to be discussed in further classes. Okay.
Okay, ma'am.
Okay, maybe we
Okay.
can close the session. I think it's already
Yeah.
delayed, right? So almost
Yes,
9:45.
Professor. Yeah.
Good night, and
Thank
then
you, everyone.
yeah, good
Yeah,
night.
thank you.